Today we will talk about function transformations. What is a transformation? Transformation is a general term used to taking a given function and doing these things to it. Horizontal translation, reflection, stretching and shrinking, vertical translation, and then doing them all at once. And then we're going to also look at symmetry. So let's get started. So I'm going to start with horizontal translation. And I'll also put the vertical in here. So let's assume you have an h and it's positive. And you have a function of x. When I want to translate that horizontally, let's call this y1. What I do to it is I take this h and subtract it from the x. And that is going to move the function to the right. If I do this, it's going to move the function to the left. Okay, well, let's look at a function to start with. So let's look at y equals x squared. Well, if I want to draw y equals x minus 1 squared, it's going to move that thing to the right one step. This is the picture of x minus 1 squared. What will it do when you have x plus 1 squared? It's going to take this and move it to the left 1. Okay, I understand horizontal translations. What happens when you do the vertical? So let's start with that again. Let's assume h is positive. You take your y. What you do is you just simply add a number to it. And that's going to move it up. And subtracting a positive number, that's going to move it down. Alright, well, let's start with our famous x squared. Picture of x squared. If I want the picture of y equals x squared plus 2, I'm going to take this and move it up. How about x squared minus 2? I'm going to take this, move it down. Alright, very good. Well, stretching and all that stuff. So what is that? That's a little bit more confusing. Let's go to the new page. Let's put stretching here. And shrinking here. I use another term, I'll tell you, just don't tell your other teachers. So if you have y equals f of x, and I want to stretch that when my a is positive, a positive number and bigger than 1, and I want to stretch this, I do this. Take that number and multiply by f of x. So x doesn't change, but y changes by a factor of a. What's that mean? Here's my x squared. Let's say I want to draw 2 times x squared. So for a given x, it's going to have this. And when I multiply this by 2, it's going to go up to here someplace. Same thing with this. Here I'm saying, what will this do? Since this thing is 0, 0 times 2 is still 0. It's going to make this stretch up. I call it make it skinnier. It's a little bit easy for me to remember. Okay? Stretch. Make it skinny. You get taller. Alright? So, same thing with the shrinking. So you have a f of x. You're multiplying by an a, but this time that a is between 1 and 0. So it's still positive, but it is a decimal, 0.5 or something like that. What will happen to it? Here's your x squared. So I multiply everything by 0.5. That means I'm going to make this half of that. Make this half of that. What will that do? It's going to stay at 0, but it's going to do this. Everything will kind of go down. Let it go. Okay, what does that mean? It's going to make it a little bit heavier or fatter. Not politically correct. Okay, it just makes it kind of like let go. Okay, you're on vacation. So for example, that would be something like this. F of x equals 0.5 times x squared. Okay? Let's make sure that you can see that. Stretching and shrinking. Alright. Now, what else can we do? We can do a reflection. How do you do that? All you have to do is just multiply by a negative. You have an f of x, and you multiply by a negative f of x. Multiply by a negative is the same as multiplying by a negative 1. Okay? So here it is. Here's your x squared, basic parabola. You multiply everything by a negative. X doesn't change, the y gets negative. Goes upside down. Okay. Negative x squared. The x squared is reflected along the x-axis. Okay. Well, can we put all this together somehow? Let's do an example. I want to draw y equals negative 2 x minus 1 squared plus 3. Okay, this is the order I do that. So I recognize I take the x squared basic parabola and do things to it. So let's do this first. X minus 1 squared. What will happen to it? It's not going to change its shape, but this is the picture of x minus 1 squared. Well, now let's take this and multiply by 2. What does it do? Stretch. But it will stay at 1, right? And make it stretch. This is 2 times x minus 1 squared. Okay? So I did that. Now I'll deal with this. Negative. What does this do? Upside down. How about I put it in the same graph? Negative 2 times x minus 1 squared. Okay? What else do I do? Ah, here it is. Let's do this in purple. I'm going to move that thing up. Okay? So x minus 1 squared, and then I'm going to move it up. So I'm going to take this upside down, something like this, skinny. It doesn't go through 0, actually it goes through 0, 1. So it's a skinny thing, but it moved up to 3. Upside down. Alright? So we are going to actually go over this when we do parabolas. You know, how you can find the vertex of a parabola by looking at the equation, and it's actually related to transformations, okay, and translations. Okay. So let's also define something else, Let's define symmetry. Now, and let's also introduce the concept of an even function versus an odd function. An even function does this. When given f of x, when you take the f of negative x, you'll still get f of x. An even function example will be a parabola. When you put x in there, or negative x, you're squaring, so you'll still get the same answer. And even functions tend to be symmetric along y-axis. What's an odd function? Odd function, on the other hand, it takes a negative x, and it doesn't spit out f of x, but it spits out f negative of f of x. What's that mean? A good example is x cubed. Look what it does. It takes a number, gets this, but it takes the negative of that number, spits out the negative of that. Okay? And those kind of functions tend to be symmetric along the origin. So practice those shifting, left and right shrinking, and for example, absolute value function or cubic function, and kind of like see how your graphs kind of change when you do things to it. Thank you for watching.